In this second video on PCB assembly, I'm going to install the MCP1642B chip on our example design. This is an MSOP package, so it's really finely spaced. You'll notice that I start by getting one pad with some solder on it, and similar to previous videos, and then I'm going to go ahead and slide the chip into place. I'm going to go through this entire video only to realize that I messed up pretty bad. I didn't really pay attention to pin 1 indicators, you can see here, so I'm actually going to put this chip on backwards. I decided to keep the video though, because I think it's a good video to show at least one example of fixing a mistake you might make. I actually go through the process of breaking my board and tearing up a pad and having to repair that. So overall, I think this is a pretty good video. When I'm dealing with this fine of a pitch part, it's really hard to get all 8 pins aligned. I want to really emphasize take your time. In this case, I ended up messing with it quite a bit and ended up saying, well, it was good enough. And it probably made it harder for me than it needed to be, let alone the chip being backward. For example, right here, you can see that that pad and that pin are almost touching, even though they're not supposed to be. And that's definitely going to kind of cause this bridge you see here and just make it not as good as it could have been or should have been. So definitely take your time. You'll also notice that I got some solder, or I'm going to suck up the solder braid here, but I'm going to end up with some extra solder on the pads of L1 at the top. So what I'm doing here, after I've removed the solder braid, is I'm just reducing those lumps of solder and kind of flattening them out, trying to absorb that down, because when I put L1 down, I want it to be nice and flat. So here you can see I'm trying to touch everything up and I'm looking at it, and remember, I'm looking through one eye of the microscope rather than both eyes on the stereo mic, and then I'm just touching up each of the individual pads. With these really fine pitch parts, it's important to do a continuity check and make sure I don't have any bridges. So I'm doing that with a digital multimeter, just checking to see what's connected and what's not. And through this process, you'll notice I kind of noted that 2 pins were connected that maybe shouldn't have been there. And so I kind of scraped at them with the tip of my probe, just trying to see if there was maybe a little bit of a hair of solder left over. But here I'm still running into that problem, and that's kind of a big clue to me that I goofed up. So this is when I realized my chip's wrong, and because the shorting I experienced was due to the chip. So I'm using a hot air gun, you can see that there on the right, to actually loosen up the chip. It's really important when you're doing this not to pull on the chip, because you can easily lift a pad. And then I'm going to go ahead and try to lay this chip back down by rotating it and putting it back. It's a little sticky now because it's got lots of flux on it. But the idea would be I can reuse that same chip and put it back in the same spot. I'm going to try to do it with a hot air rework, and this would normally be fine. But one of the problems with this is that I ended up actually bending some of the wire leads a little bit on my first installation to try to get them in there. But as you can see with this hot air rework, I'm doing this at high speed at this point. You can definitely see that it laid back down. But maybe it's a little bit on the messy side. So next thing I'm going to do is I'm going to touch up each of the leads like you would expect me to do. I'm going to try to make sure I get a good connection, and then once that's done, I'll go back through and check with the probes. Trying to push that lead back, you can see me actually putting pressure. Seemed like a really smart idea at the time, but what it actually did is it bent that pin 2, all the way into pin 1, and then when I tried to bend it back, I ended up noticing that pin 2 was actually loose in the package, and pretty much I was not confident it was ever going to work again. And so my final solution is just to pull the chip off and to replace it completely. Here I just added a little bit of extra solder flux to make sure I have good solder flow under heat. You can see it bubbling away a little bit now. Just to make sure that I do have good solder flow. And of course, trying to push that thing back I felt I really needed something to pry with, so I just kind of grabbed something on the bench, which is a screwdriver, trying to bend it back flat. Didn't really think about my own strength, and this is where I actually separate that pad, like I said I was going to do earlier in the video. But luckily that gives us an opportunity to learn how to just add a blue, usually called a blue wire, but a wire to essentially bridge that. Where I'm really seeing the problem is when I went to check continuity, and then I start to debraid it, I notice, and you can even see it there, that there's a weird angle to that pad. Sorry about the video quality here. The camera using the microscope is pretty low quality. And I just give up and take the chip off, clean it up so that you can actually see, and there's that pad, that number 2. It's definitely not as it should be. So here I'm just cleaning up so I can see it well, use a little bit of flux remover so I could see the pads and the microscope really well. But I'm going to move forward with actually installing the new chip. Excuse me, I have installed the new chip. I'm going to move forward with installing a few other parts and then actually getting the trace replaced. You can see there in that really quick scene that I showed an unstuffed board and showed where the trace should go, but it basically goes to the pin between R3 and R4 to pin 2. I'm not going to use the old pad that's been there. I'm just going to try to solder wire directly to the pin. This is doable. It's definitely a fine process. It takes very gentle hands, but that's what I was going to do. So we'll go ahead and head through actually installing a few more parts, and we'll get to the spot where I was actually trying to finish up that wire, and then we'll see how I did there. So right there you saw my thumb come into view. I was basically trying to hold the wire straight where attached to the chip while I bent it to make this U shape to solder down to the next point. And I kind of did that, but still the bending that I was doing was enough that you'll see that it actually came loose from the pin of the chip. So then I tried to fix that. Trying to fix that, I end up with a situation where I hook 2 pins together. Trying to fix that, and I noted with the continuity, I end up having to cut some of the wires, and it goes on and on and on and on. And so that's kind of the problem here. Ultimately, I just removed the wire I had, used a longer one, and reinstalled it from scratch, as you can kind of see here. And this time it took, had good electrical connection using the continuity meter. This is not a very high current connection. This is just for the biasing, and so I kept this in the final design. Doing that final continuity check to make sure everything is good to go. So kind of the lesson here, of course, is make sure you put your chips in the right way, and if you do lift a pad, it's solvable. It just takes more than a little bit of time.